Okay, this is a college algebra video on polynomial functions, graphing polynomial functions. And so you have a worksheet, so I'm going to go along with the worksheet. And so it gives you this generic polynomial function, f of x, and it says f of x is equal to a sub n, x to the n, plus a sub n minus 1, x to the n minus 1, plus some more terms, a sub 2, x to the 2, a sub 1, x to the 1, plus a sub 0. This is a big, long, generic polynomial term. You don't need to be afraid of that. I'm going to tell you what it means. What makes this a polynomial, what makes anything a polynomial, is the fact that the coefficients, the numbers in front of the x terms, are real numbers. They don't have to be whole numbers. They can be fractions. They can be radicals, but they just can't have an imaginary part to them. They can't have an I in them. And then the second thing that qualifies this to be a polynomial is that the powers, the x powers that they're raised to, are non-negative whole numbers. That means they can be 0, they can be 1, 2, 3, or 4. They cannot be negative. So for instance, this is not a polynomial. Not a polynomial. Something like this. F of x is equal to 3x to the 1/3 minus 2. What's making this not a polynomial is this power right here, the 1/3. Fraction powers are radicals. So this is really 3 times the cube root of x minus 2. This is a radical function, not a polynomial function. Okay, what if they give me this? G of x is 2ix plus 7, not a polynomial because this coefficient, it has got an imaginary part to it. Here is another scenario. H of x is 4x cubed minus 2x squared plus 3x to the negative 2. This is okay, this is okay. This little negative 2 is not okay. That makes this 3x to the negative 2 is the same thing as 3 over x to the positive 2, making h of x a rational function, not a polynomial. So these are not polynomials. So as long as those are, that's what a polynomial is. In fact, you have dealt with polynomials for much of your life. Y equals mx plus b is a polynomial. That's a line. So y is equal to x squared is a polynomial. That's a parabola. That you've already seen a lot of things that are polynomial. That's mostly what you've dealt with. So in this case, there's some blanks on your worksheet. It says the degree of f of x is, and so this is a generic polynomial, but if we look at it, it's n, the power is n, and then it's n minus 1, so that's smaller, and it goes all the way down to x squared, x to the first power, and this is technically x to the 0. So the highest power is n, the degree is n. The degree of this polynomial is n. Okay, the maximum number of turning points. So for instance, if we have a polynomial, the graphs of polynomials are very nice because of this, because none of this kind of stuff is in there. It makes their graphs smooth and continuous, and when they turn, they go up and down and up and down and stuff like that. This is what they generally look like. Every place it was headed up, it was increasing, and then it decided to decrease. That's a turning point. It was going down and it decided to go up, turning point, turning point, turning point. And so the maximum number of turning points that a graph can have, that a polynomial can have, is equal to n minus 1, the degree minus 1. This is the max number of turning points it can have. Now, a graph is not obligated to take on all of those turning points, but it can have that many if it needs to. So what would this have to be? It would have to be this picture right here. Let's just say it went on like that. It has 1, 2, 3, 4 turning points. This polynomial would have to be of degree 5 or larger in order for it to look like that. Okay, then zeros are where graph touches the x-axis, and so just fill in the blank and we'll explain this. It says a 0 with an even multiplicity. What you want to put there is it bounces or it touches, and terms. A 0 with an odd multiplicity, it will cross. This is the behavior at the x-axis. Okay, so we'll understand more about this as we go. And then I have this really big chart in the middle. I used to use that chart a lot for the end behavior. I don't, we're going to fill it in, but I don't go by that chart as much. I learned kind of a better way to think about it, and I'm going to talk about that with you guys. This is to determine the end behavior. So, for example, the end behavior, I just need the space, so I'm erasing this. The end behavior of any polynomial can be determined just by looking at the leading term right here. This leading term. The coefficient here, a sub n, and the degree. So this is how it works. If the leading coefficient a sub n, if a sub n is positive, if it's positive, then it's going to be up to the right, okay? There's two situations where a sub n could be positive. If a sub n is negative, then it's going to be down to the right. The right behavior is going to be down. And I'll make sure I explain what I mean by right. Now, if the degree, n, is even, then it follows the right behavior. All right? So if n is even, then it's going to go upright if it's already right. This is for n is even. The left will follow the right. If n is even, it's going to follow the right. It's going to be down right, down to the left if n is even. It will follow the right behavior. But if n is odd, and so I'm going to use a different color for the odd. If n is odd, what's going to happen? Well, if n is odd, then the left behavior is going to switch up from the right. It's going to go opposite. So if it's odd, then if right is going up, then left will go down. N is odd. If r is going down, then left will go up if n is odd. So you can look at the chart that I have on there. I think I put some, I have some this. Y is equal to x squared. Okay, the leading coefficient for emphasis is 1. 1 is positive. That means it's going to go up to the right. Okay, the degree is 2, which is even. That means the end behavior on the left is going to be up to the left. Now, what does end behavior mean? End behavior means what is happening to the left at negative infinity and at the right end of the graph, positive infinity. If we think of the graph x squared, it's a parabola. That looks like this. And so if we think about this parabola, way over here at x is negative infinity, it's going to be going up. And then way over here at positive infinity, it's going up. So that matches that behavior. What about if we have y is negative x squared? I think you guys know that this guy looks like this. But let's go by this stuff we just learned. The leading coefficient is negative. That means down to the right. But the degree is even. That means the left behavior will match the right behavior. So it's also down to the left. And that's what is happening here. Down, left, down, right. I think I gave you, on your chart, I gave you something like y is equal to x, okay? This is a line, y equals mx plus b. You can see that the slope is 1. There's a 1 right there. The leading coefficient is 1, and it's positive. That means it's up to the right. But the degree is 1. That's an odd number. That means the left behavior will switch up. It's going to go down to the left. If we were to graph y equals mx plus b, it's going to look like this, basically. Down to the left, up to the right. Y is equal to negative x. This has a negative slope. This guy looks like this. Oh, that's a bad axis right there. Pretty sloppy. There it goes. Okay. If we go by this little rule we just learned, okay, let's say negative leading coefficient down to the right. Odd power, it's going to switch from the right, so it's going to go up. left, up, left, down, right. That's what end behavior means. That's what end behavior is. So, let's go through these three little examples and we'll learn how to graph a sketch of a polynomial. Now, these are not accurate graphs. This is just a sketch, but that's okay. That's what I want us to learn how to do. So, here we go. The first thing on our sheet says, let me see what this is. Okay. The first one is f of x is equal to x squared times x minus 4 times x plus 1. X squared times x minus 4 times x plus 1. Okay, so they say A lists each real zero and its multiplicity. If we were to set this function equal to 0 and solve for x, then we would get the zeros of this function. Set x squared equal to 0 and solve, we're going to get x is equal to 0. That's what this guy gave us. Set x minus 4 equal to 0 and solve, we get x is equal to 4. Set x plus 1 equal to 0 and solve, we'll get x is equal to negative 1. These are the zeros of this function. Then there's something called multiplicity. And in the word multiplicity, you can hear the word multiply. And when you think about multiplying, you know that it's how many times something occurs. 2 times 3 is 6. You hear the word times. How many times does x equal to 0? Here, 2, x and x. There's 2 of these. The multiplicity of this root is 2, or of this 0 is 2. How many times does x minus 4 occur? 1. The multiplicity of this 0 is 1. How many times does x plus 1 occur? Only 1. The multiplicity of this is 1. Why do we care? Because it affects how it's going to act at the x-axis. A multiplicity of 2 is an even number. That means at the x-axis, the graph will bounce. That's what it'll do. It will touch and turn. Because the multiplicity, not the 0 itself, but the multiplicity is odd, it's going to cross. The multiplicity is odd, it's going to cross at the x-axis. This information, together with the end behavior, we can create a sketch of this. Let's see, what do we need to know? The end behavior, the leading coefficient, and the degree. This is a positive, positive, positive. The leading coefficient is going to be positive. We don't have to know the number, we just got to know whether it's positive or negative. If it's positive, we know it's going to be up to the right. Okay. If you think about it, x squared times an x would be x to the third, times another x would be x to the fourth. The degree of this is going to be 4, which is even. Another way you can think about finding the degree is just by adding up the multiplicities. 2 plus 1 plus 1 also equals to 4. The degree is 4, it's even. That means the left behavior will match whatever the right behavior is, up, left, up, right. Here is our x-axis. We're going to mark our zeros on here. 1 is at negative 1. This is negative 1. 1 is at 0. This is 0. And 1 is at 4. This is 4. You don't have to be all that accurate about where this is. It's just we're sketching. It's okay. The end behavior is up, left, up, right. So that means that my graph is coming in from negative infinity, and it's coming up from negative infinity. It's going to be coming down. And when I get to negative 1, the behavior is that it will cross. It's going to come from up here, and it's going to cross. And when it gets to 0, the behavior is that it will bounce. So it's got to somehow turn back around and get up here, and it's going to bounce back down. And then when it gets to 4, it's going to cross again. Some kind of little W shape is what I get for this. If I'm interested in knowing how far these turning points are, I would put in some numbers and do some more math to figure that out. But this gives me a pretty good sketch, not too hard to find a sketch. Let's do the next one, which is f of x is x plus 5 times x minus 1 squared. X plus 5 times x minus 1 squared. Okay, what does it say? List the zeros and their multiplicities. If I set this equal to 0 and solve, I'll get x is negative 5. If I set this equal to 0 and solve, I'll get x is 1. What are the multiplicities? The multiplicity is 1. This will cross. The multiplicity is 2. this will bounce. The last thing I need to know is the end behavior. So, was there other stuff? Oh, find the y-intercept. Did I do that? I didn't do that. This is how you can find the y-intercept. You can let x be 0 and solve for y. So if we let x be 0 and solve for y, it's going to be 0 squared times 0 minus 4 times 0 plus 1. But 0 times anything is 0. So we know that 0, 0 is the y-intercept for that one. I forgot to do that step a minute ago. Okay, now let's do this. The leading coefficient, it's positive. This is going to be a positive, so it's going to be up to the right. And the degree is 1 plus 2, which is 3. That's odd, so the left behavior is going to switch from what the right is. It's going to be down left. So right here, let's mark our graph. Here's a 0 over at -5. Here is a 0 at x is 1. And we know that it's down to the left, so my graph is coming up from somewhere. It's down to the left. And when it hits -5, it's going to cross. And then when it gets to 1, it's going to bounce back up. Something like that. What is this point? This is not an accurate graph, but they asked me to find the y-intercept, so let's just find it. F of 0 is equal to 0 plus 5, 0 minus 1 squared. So this is going to be 5 times 1, or 5. The y-intercept right here, this point right here is 0, 5. All right, the last one we're going to do is f of x is equal to negative, f of x is negative x plus 6 times x minus 7 times x plus 2. All right, let's go through and find the zeros. If I set this equal to 0 and solve, I will get x is equal to negative 6. X is equal to 7, and x is equal to negative 2. This 0 has a multiplicity of 1, it will cross. Multiplicity of 1, it will cross. Multiplicity of 1, it will cross. The leading coefficient is negative, so that means it's going to be down to the right. The degree of this polynomial is 1 plus 1 plus 1, which is 3, which is odd, which means it will switch from the right, so it'll be up to the left. So let's sketch this guy. Here we have a 0 over at negative 6. Here is a 0 at negative 2. And here is a 0 at positive 7. It's going to be up to the left. That means it's coming in, and when we get to 6, it's going to cross. And when we get to negative 2, it's going to cross. And when we get to 7, it's going to cross. So our graph will be coming in from up here. It will cross, it will cross, it will cross. Some kind of sketch like that. If they want me to find the y-intercept, this point right here, let's go ahead and do that. Let's see, f of 0 is going to be a negative times 0 plus 6 times 0 minus 7 times 0 plus 2. A negative times a negative is a positive. This is going to be 42 times 2. This is going to be 84. So even though this is obviously not the scale, the y-intercept, I'm just going to label it right there, is 0, 84. And that is graphing polynomials.